Okay, so hello there, everybody. We're now on our video in the measures of variation. We're still in the introduction of statistics or introduction to statistics playlist, and this is part of the numerical summaries of data. So we're done there with the measures of central tendency. Here we're going to have and talk about the measures of variation. So the measures of variation is also called the measures of dispersion, or in some books they also call it the measures of variability. Okay, so I believe there are some major books that call it variability rather than variation. What does it do? It describes the degree of dispersion or scatter or spread of scores in a distribution. So it refers to how spread a group of scores is. And to see what we mean by spread out, we consider the following graphs. So graph 1 or exhibit 1, shall we see this graph? um just to let everyone know the mean of this graph or this exhibit A, the mean, I just want you to let to net to I just want to let you know that the mean is 7 for exhibit A, and for exhibit B, the mean here is also 7. Okay, so looking at exhibit A, the graph is pretty much um as you can see, the frequencies of the six is 6, the frequencies of 7 is 5, and so on. As you can see, the graph is somehow clustered and grouped together within that mean there, compared to the exhibit B, wherein the highest frequency is only 4, which is 5, and then most of them are lumped within this mean, are not really lumped, it's scattered compared to exhibit A. This is more lumped, this is less lumped. Okay, so what we want to say here is that these graphs represent the data of two quizzes, for example. The mean score, as I said, for each quiz is 7. But despite the equality of means, you can see that the distributions are quite different. So take a look at this again, this two exhibits, set A and set B. Okay, you can see that the scores in quiz 1 is more densely packed than those of quiz 2. No, though both of their means are 7. Okay, so the difference among these students were much greater on quiz 2. The difference on the scores is that is compared to quiz 1 or set A. So that's here. Okay, so what we want to do is to determine, or we need some measure. We can get the measures of central tendency to give us a characteristic or a general characteristic of the distribution, but it doesn't give us any information about how spread the scores are. And we need that information. As you can see in the previous slide, that both of them have the same means, but the distribution is not that the same. So we need to introduce one measure that can tell us how spread the scores are. So that measure is what we call the measures of variation or variability. So the terms variability, spread, and dispersions are synonyms and refer to how spread out a distribution is. Just as in the section on central tendency, where we discuss measures of the center of the distribution of scores, in this part, we will discuss the distribution, which is the measures of variability. So we will try to first get into consideration these two sets, a male and female, which is A, and B is female. Male is A. The scores in a particular quiz are as follows, and we are tasked to to construct a dot plot for both sets. So if we're going to do that, or actually we can just put it here, get the x bar. This is x bar, sorry. This is x tilde. And since this is x bar, this is the mean, of course. This is the median here for x tilde. And this is the sample size. Shall we call it size? I think it's understood as a sample. So we need to first get the n, how many they are. So 2, 4, 6, 8, 9. I think it's clear that they're both 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, this is 9. So we need to get then the mean of the distribution. So what we need to do is to add them all and then get the mean. So we have 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is gonna give us 18, 18 plus 8 is gonna give us what, 26, 26 plus 9 is gonna give us 35, 35% is 45, 45 plus 12 is gonna give us 57, 57 plus 15 is going to give us what, 57. plus 15 is going to give us a 62. Is that correct? So 7, this becomes 12, this becomes 18, this becomes 26, this becomes 35, 45 out here. And we have 57, and then we'll plus 15 to that. What's going to be the answer? That's going to be 72. Okay. Here we have a 3, this becomes 10, this becomes 17, this becomes, what's the answer? 24, this becomes 32, and then we have 40, 48 over here, and 57, and we need to add a, I think actually we ended up with the same number. So 72, we need to divide it by 9, so that's pretty much 8, and both of their means are 8, as we can see. Okay, next is the median. What's the median? What's the middlemost score? So good thing for us, it's actually already in an array. So the median is the middlemost score. So since it's 9, so we just need to locate the middlemost score, and then that's pretty easy to see that the median is both 8. Sorry. Now, I think it's pretty clear that we can see that the sample size is the same, the mean is the same, the means are the same, the medians are the same, but there's something wrong with the distribution wherein it doesn't tell us any information about how scattered or how the distribution of scores are put into the given here, how spread they are, how dispersed they are, how distributed they are. So the measures of central location, what we can say about the remarks is that the measures of central location or central tendency do not give an adequate description of a given distribution. It also does not describe how the observations are spread out from the average. So we need to determine that in order to give um, a precise description or a characteristic of the given distribution. So what our answer here, our solution, is to introduce the different types of measures of variation or the measures of variation. So we have number one is the range, standard deviation, and the variance. So there's actually a lot of them. We have the interquartile range, we have the mean, average, deviations, and such. But we're going to focus on the three, which is the range, standard deviation, and variance. They're pretty much the ones which are uh, popularly used. So we're going to start with the range. The range is just literally the difference between the highest and the lowest observation, or the highest and lowest value. That's just a simple subtraction. This is not very useful because it considers only the extremes, and it does not take into consideration the bulk of observations, which is mostly in between. So let's try to consider again that the range of the two previous given sets, these male and female quizzes, I think we can see that the range for set A is 15 minus 3, that's going to give us 12. That's pretty much clear. And the range for set B is 15 minus 3, so also 12, which is also clear. But we can see that the range is the same, but it doesn't really give us an exact, an exact picture of how the graph looks like. We can see in the dot plot that it looks like this for this is set A, rather set B, and this is set A over here. I think it's pretty clear that set A is pretty much spread out, and set B is lumped within this area. But given the range, it does not give us an adequate does it give us information about how that happened. So we can say that using the range is not that effective. We will only use the range when the data are too scant or too scattered to justify the computation of a more precise variation measure. And only if you want a knowledge of the extreme scores or a total spread is all you really want. But as you can see in the previous one, it's not that effective to see the total variation, since we can see that the dot plot, it's not that they're not the same as far as the variation is concerned. One is lumped, one is spread out. But the range doesn't give us that information. So we need a more stronger measure for variation. So we only use the range for such reasons such as this. So we need to have a more stronger measure, and that stronger measure is what we call the standard deviation. So the measure of variability that is based on a difference between the value of each observation and their mean. So that's the essence of the standard deviation. The difference between each value, x of I, and the mean is called a deviation about the mean. And this is the most important, commonly used in measure of variation, together with the mean as a measure of central tendency. So we can say that it's since we call the mean as the most stable measure of central tendency, we also call the standard deviation as the most stable measure of variation. So we have a formula for the raw score method. This is the formula for this. But take note, we won't be applying it here as far as this slides are concerned. There are a lot of examples on a separate video, which makes use of makes use of a statistical softwares, which makes our lives easier. Wherein we're not gonna make use anymore of the raw score formula. Okay, so we use the standard deviation. Okay, when the statistic having the greatest stability is desired. Again, it's the most stable measure of variation. So we recommend using this. And the coefficients of correlation and other statistics are to be computed later. And we need for example, the Pearsonian skewness, the standard score if we need that. So we pretty much need a standard deviation there. And the mean is the preferred measure of central tendency. So whenever we use the mean as the central tendency, SD will follow, or SD or standard deviation, good, short for SD. Okay, so that's the standard deviation. I have here some examples, but we're not going to follow this. Not going to do this for now. This one, we can actually get the standard deviation here for both sets, but it's gonna be the tedious. I'm going to make a separate video for this, and also this one. We also have one example here. I'm going to make it on a separate video. All right, so kindly stay tuned. Variance. Now, this is the last one in our slides. The variance is actually just a simple square of a standard deviation. So just like that. So you have the standard deviation, square it, and you get the variance. So the population variance and the sample variance are like this. So the symbols are S squared. For the population, it's sigma squared. This is because your SD is written as sigma, only sigma for the population, and your SD for the sample is just an S. So you put a square to make it a variance. See, the variance is of little use compared to standard deviation, and especially in descriptive statistics, because its calculated value is expressed in square units of measure, and we want the square units to be away because we want a standard of, the normal units, not the square units. So some historical notes on the measures of variation, just a little bit of fun facts. Historical notes, it's Carl Pearson who introduced or coined the term standard deviation and range, introduced the concepts of range. And actually, he's the one who coined the term standard deviation way back in 1892 to 1893. Okay, and that's it for this video. That's the end of the measures of variation. Actually, that's actually the end of the what do we call that? That lesson in numerical summaries of data in statistics. So we're still in we're still in our playlist in the introduction to statistics. So I'm again here, Sir A. I hope you learned something from here, and I'm very glad that you have had watched this video until the end. So thank you very much. Don't forget to hit that like button, please, and make sure to subscribe. Okay. So thank you very much.